everybody is aware we are facing difficult times now, but we should not forget that the global challenges have been out there even before the pandemic. In this regard, our guest presenters, beside their remarkable computational skills, will share their vision on topics such as sustainability, waste management, learning from nature, local identity, heritage, circular economy, new promising fabrication technologies, urban transformations, or social housing. This means to me they are all seeking the greater good. As president of the Ibero-American Society of Digital Graphics, SIGraDi, and on behalf of our community, I want to welcome all the presenters and panelists to the second version of the World CAD PhD workshop organized by SIGraDi and hosted by the Universidade Federal de Juiz de Fora, Brazil. Welcome to the 2021 World CAD PhD workshop. Now I want to invite Dr. Rodrigo Martin-Iglesias to lead the session. Rod, please.
Thank you very much, Marcelo. Welcome all. Well, we'll start this first session of this workshop, this international global workshop, and I want to start thanking and naming the panelists for today. Will be Birgul, Çolakoğlu from ACADIA, Jane Scott from ACADIA, Huda Salman from ASCAAD, and Tian from CAADRIA. If you want to present yourself very briefly, your university, and say maybe a few words very briefly, it will be great. And then we will start with the presenters, the presentations of the students present here. I have the videos, and we will take like around 20 minutes for each presentation and feedback from you, the panelists. So if you want to start, Birgul, and then maybe in the same order that I named you, you can present very briefly yourself.
Okay, so my name is Birgul Çolakoğlu. I am representing eCAADe in this panelist workshop. I'm from Istanbul Technical University, and my research area is computational design, and late 3-4 years on circular economy, intersection of circular economy with computational design.
Thank you, Birgul. Jane?
Hi, my name's Jane Scott. I'm representing ACADIA. I am a research fellow in the Hub for Biotechnology in the Built Environment at Newcastle University in the UK. And I'm currently pursuing a fellowship called the Living Textile Interface. Yeah.
Thank you very much, Jane.
Huda Salman. I'm joining you from Scotland, representing ASCAAD. I am from the University of Robert Gordon, and I'm presenting also the research degree coordinator for the schools, Coastal School of Architecture and Built Environment. My research focused on architecture and architecture technology, and also the efficiencies within digital processes and computation. Thank you.
Thank you, Huda. Sky?
Hello everybody. I'm representative from for CAADRIA. So I'm from Harbin Institute of Technology in China. So my research is in participatory design. So I work with VR, AR, and computational stuff. So yep.
Thank you very much. Well, we will start with the first video. Let me share my screen. I hope you can see it. And the first video is from Ali Mahdi.
Hello everybody, this is Ali Mahdi introducing my PhD thesis entitled in extending.
Let me know if you can hear and see the video, okay?
Yeah, we can see it okay. The audio, you may need to check when sharing the screen that it says like optimized audio.
Let me see if I can optimize the audio. I will check again.
When you share the screen, there is two checkboxes in the bottom of the...
I'm checking the boxes.
Yeah.
So now...
Hello everybody, this is Ali Magdi introducing my PhD thesis entitled in extending the morphological capabilities of architectural programmable schemes using bio-inspired methodologies. The research problem will introduce three main issues or sequential issues. The first one is how to use a new adaptive techniques for a facade design using a kinetic motions or different morphological capabilities for a building schemes, but usually building schemes utilizing technological sensors, high electrical involvement, which are not durable and efficient enough because of its high cost, maintenance, and running power. Also, while using natural self-assembly material, these materials have limited type of morphology interactions. Also, they have limited types of motions, which lead the material to lose its efficient durability and function. Also, while using these programmable matters that exposed to different environment with different conditions, with level of humidity and temperature differs from location to another, and these factors directly affecting the material actuation and controlling the process. In the first part of the research, there will be a classification to identify the selected material to be studied and tested, and also the external stimuli that will affect the material during the research and the experimental methods and experimental phases. Also the type of movement and motion, the type of controlling and actuation, and also the time that will the material respond and the scale of the material. Then the research will concern to identify the programmable materials with the different morphologies and actuation types. Then the research will identify the material class, the material type, global kinematic motion, actuation, and control type, and also what is the building scale that the research will concern on. In the second part, the research will concern the biomimicry process, focus on the hygroscopic material scope, where the materials swell and shrink under different level of humidity that have been affected from the external environment and stimuli. The second biomimicry process will concentrate onto actuation process scope to learn from turney devil and horned lizards skins the adaptation process while absorbing the maximum level of humidity and moisture from the environment and how they can transfer it through their skin. And then the research will implement these inputs and this database into an experimental phase through testing material behavior and motion by using different materials, laminated materials, and also under different humidity and temperature levels. And based on the experimental phase and the observations, the research will conclude a morphological matrix of the material morphological capabilities. For instance, if we took in consideration the hygromorphic materials parameters, like material type, artificial, wood, cut, orientation, lamination, perforation, and so on. So how these types and how these parameters can affect the material to make a specific morphology and motion, like twirling, rolling, rotating, bending, twisting, and so on. So based on these parameters and these morphological capabilities, we can conclude for each morphology and for each deformation the parameters that affect this specific transformation. So based on it, we can conclude in the research a morphological matrix for those the transformation and deformation based on a specific parameters of the material utilized in the research. From this point, we can conclude a cumulative programmable composite with the different layers and different parameters to produce a specific morphology that adapt with the external environmental factors. For a verification process, a prototype of designed programmable material unit will be fabricated using 3D printing, 3D CNC milling machines, and other digital equipment to produce a real scale unit to be tested under different condition or a specific condition for a skin or an architectural skin at the end of the research. Computational and digital scripting and programming will be introduced in this part of the research. Also, to make the programmable skin workflow more parametric, the actuator or the material parameters will be connected to the final morphological type and transformation. So based on the inputs of the parameters or merging between multiple parameters, the script will conclude a specific morphology based on these inputs, and so on. And then the simulation will be involved also to know how much the morphology or this morphology will be efficient enough for the building and human comfort inside the spaces. Thank you.
Well, thank you, Lee. Now maybe you can introduce yourself briefly. I mean, your university background, very briefly, and then we can go to the feedback of the panelists.
Okay, thank you for all of you. My name is Ali Magdi. I'm from Alexandria University, making my PhD in Alexandria University, but I'm working in the American University in Cairo as a teaching assistant and research assistant. And also I made my master's in the same topic with the support of an Erasmus Plus scholarship in UK. And also some sort of, I made some sort of researches in the American University with great staff, Dr. Shiuk Murad and other staff. And I'm very happy today to know how much my research is efficient and how I can improve it to be more successful. Thank you all.
Thank you, Ali. Who does want to start? Maybe it can be in the same order or just voluntarily. I mean,
I'm happy to start.
Yeah, please, Jane.
Well, firstly, thanks, Ali. I thought it was a really clear presentation. I thought you kind of showed the method and the experiments that you want to undertake in a really systematic way. And I think my initial feedback was I was just really keen to get a bit more detail on every aspect, I guess, because I think you, in the first set of kind of questions when you were analysing the problems with or the gap in knowledge at the moment coming from these kind of mechanized systems into passive systems, you identified the importance of, for example, a very specific environment and a very specific material system to be kind of critical in the development of a passive material system. And I think you've kind of identified that that's really important. And so it would be nice to see all the way through, you know, are you dealing with a specific climate? Have you thought about where in the world you're going to develop these materials for? What kind of materials are you looking at? I did notice that the final image of the thorny devil inspired skin did have some materials kind of identified, but it'd be really interesting to talk in more detail about kind of what those materials are, how they work together, how they work within a composite system. So yeah, my feeling was it was about kind of the details, which I was just really keen to understand, to be honest. I thought it was very interesting. And then I'd love to hear a bit more about the thorny devil as a biomimetic model, because I think it's quite an interesting, an interesting little model to look at. So I'd like to know how that would translate through in your research.
I'm working about for like a hygromorphic material, and a hygromorphic material in desert places or locations need more humidity to be transformed and to be deformed. So because of that, I inspired from thorny devil, as he can absorb maximum humidity in the desert places and locations. So from this scheme, I can manipulate, or I can learn from the thorny devil how it can absorb the maximum humidity through its capillarity and it grooves in his skin. So from this method, I can make it my hygromorphic material more efficient to absorb the maximum humidity in the desert and the other places that have a high level of humidity, to make the hygromorphic material, or my hygromorphic material, at the end of the day, more efficient and deformable.
That's great, thank you.
I want to remember the panelists. Sorry, I want to remember the panelists that you have a form for the evaluation, that because then we have to choose the best presentation. So just to remember that, and then Birgul, please.
Okay, hello Ali. I also find it very clear your presentation. It was step by step explaining your idea, but I will just take from Jane comments where that we need more details, because you are speaking about the biomimicry, looking to the thorny devil's skin humidity absorption, how it absorbs humidity. But will you be able to conduct research on that aspect in your future steps of the design? Because this is really what we are lacking in architecture. We come up with those great ideas, but we don't communicate then with the scientists. So this is the research that will come from this scientists, biological scientists or biomimicry scientists. I think we can only use their results to generate the some approaches for material development. So my concern is that, did you have any connections related with this issue with the researchers? Because I think that you will need it, that we are, as an architect, we are not capable of doing that in-depth research in different, in biology, for example. So it may stay in very superficial, but if you want to really generate material, that is a collaborative work, like a joint scientific and designers joint work.
Okay, I have two strategies for this. The first one is I have two strategies for this. First one is about the material. So potassium chloride or silica gel or or some sort of chemical materials can absorb maximum humidity from the environment. So we can add this layer to our laminated layer or to our design layer. And the other strategy is about the forming, the engraves and the 3D forming of the skin. So we can learn from the SIGraDi how it makes a capillarity canals that absorb the maximum humidity and make it shaded to not be evaporated after that. So we can learn from the SIGraDi the two strategies. The first one, the modeling itself of the skin and how it can prevent or it can absorb the maximum humidity with the shading areas or capillarities areas. And also in the other strategies, the material of each skin, like silica, we can make it in the real life with silica gel, potassium chloride, or other chemical materials that absorb humidity from external environment. So I think this is the connection between the two.
Okay.
Thank you. Sky, Huda?
Yeah, I have to also say, very good presentation, very clear hypothesis, and we understand where you come from. I really love your experiment, all the bendings, different twisting and everything. It's very nice. But I have to actually, I have one few same question. One of them is same as Jane, where because the thing is, your research question is still not very clear. Because the main idea is, I would like to ask is whether you are really looking at the cost efficiency, and that will actually come to the question where, whether these things come from which region, whether it really cost effective, if the material is being shipped from places to places, all this humidity, whether it fits the region, then, this is, relate to the research question. And if your research question is the programmable, so where is, how do you actually program this? You were looking at the humidity, the figures and data and everything. So if that is the case, then I will have to say, you have to come up with a much more clear program details, whether, whether it fits the different, you have all these different twisting, you have all these different bendings, and how does it relate to the humidity and all this humidity when you put it on a facade, how does it actually relate to the whole environment? Whether the twisting actually fits the environment and actually really reduce the building performance, not reduce, increase the building performance, that kind of stuff. So we have the fact that this is still not really very clear, we can't really ask a very clear and specific question. So I'm just wondering, you have, what is really the research question on your side?
Yeah. About the second question about how it can be programmed. So I think after multiple experiments and after inputs, so we have like multiple factors for the specific material that I'm using, like hygromorphic material. So these factors I can make in a programmable scripting, so that I can put like a script or a small script with the parameters, and each parameter, how can it affect the real time material at the end of the research. So if I have like making like multiple experiments in the lab, so I have like multiple outputs, so I can make it like in a script. So if I higher the level of humidity at this with this parameter, the material will behave or will act like that. So I can make like a matrix, and after that I can take it to the final scripting. So in the script I will have like the parameters of the material and the output at the final script. So
yeah, because this actually gives me the question, because you are actually going too deep into the scripting, but you have to put your step back and ask, what's the purpose of this program? How does it help the architecture to actually improve the building performance? How does this program actually works to actually relate to the building performance? So right now you're answering how you can program, what you can program, but what is the purpose of it? How does it help the architecture of the building? This is the question you have to answer to make this the research much more purposeful.
Yeah, I think you're right, but I think what I am purpose for is about like a flexibility in design. So you have like multiple morphologies under different conditions. You have like a flexibility as an architect to design whatever you want. If you want to make like a morphological pattern with twisting or something like this, if you have a specific design, so you can go to our matrix and see how can you make it twisted with like the parameters and the output. So it is like a method or something like this to open the doors for the designers. So you can design whatever you want, and you have the final effect at the end of the day.
Thank you. We have 2 more minutes, let's say. So Huda, please.
Yes, thank you. Thank you, Rodrigo. Definitely Ali is the only one I think has all the answers. The presentation was clear, and thank you for the, sharing that knowledge with us, because I'm sure you are the only one who know all the details of your project. However, I just wanted to start with a very generic question, really. What is the effect of your intervention and the new system that you try to innovate in? For instance, as Sky mentioned, I think we're looking at what aspect of performance you're focusing on within the facade. This is one question. The second one, you are looking into one variable, which is humidity. Am I right?
No, it's like humidity and temperature.
And temperature, both. Okay.
Yeah.
Can you let me know just the percentages and the highest and the minimum temperature that you have? I mean, the range of temperature that you are focusing on within the design aspects?
I think we have made like a research before about this factor. So the wood or the hygromorphic material like wood, timber wood, it also influenced by humidity and also by temperature. So because of that, in my PhD, I'm concerning the 2 factors together. And I think in maybe in desert places or something like this, maybe it will be a higher level of temperature. But I'm working on like a variety of design factors. So maybe at some points I need the temperature to be like 25 Celsius. So how can I work with this temperature? And if it is higher to be like 40 Celsius, how can I work at this temperature? So I'm concerning about the method, not about a specific temperature or a specific humidity. I'm working about the method, how you can act, how you can interact with this temperature and the humidity at any place or at any factors, using the factors that we are going to conclude at the end of the research. So if we hire at a humidity level, so we can the material will work and will deflect. So if you have a lower level of humidity, so I can laminate something like potassium or something like a chemical material that absorb maximum humidity, and something like the temperature and other factors. So we have like a factor of thickness of the material. So the thickness, the higher thickness, the lower deflection, and the lower thickness, the higher deflection. So we can work with these parameters for a specific environment. But overall, I'm working about the methodology of how we can design something like this, and what is the factor that affect the design at the end of the research.
Yeah, but the success of the method will be totally dependent on the range of temperature and also the humidity percentages, right? Because you want to use that methodology later on. So the context of the applicable or the applied research would be very, very important and relevant to how the facade will perform. Okay?
Yeah, but for sure, while I'm working to mimicking a SIGraDi level in the desert places, so I'm working with a higher level of temperature. I will work in my case study in a higher level of temperature for sure.
Yeah, because 25 is very low. Okay.
Yeah.
Thank you very much.
I'm working about the methodology, but I will concern in a higher level of temperature because I am mimicking SIGraDi level. So it must be efficient at the end of the research.
Okay, all the best. Thank you very much.
Thank you.
Well, thank you all. We are in the time limit, so I will just make a little advice, not a question. Maybe you're trying to make a very universal kind of methodology, and when you say that this option of the designer of making the thing that you want to do in every context that you can imagine, maybe it's a good purpose in general, but I think for a PhD thesis, maybe you can focus a little in one case to verify, maybe to contrast the hypothesis and to make sure that you are in the right track, something like that, like to narrow a little the scope, maybe at the end on the programmable composite or something like that. Just an advice, not a question.
You're right. Yeah.
Sorry.
Thank you all for your comments and your. Thank you.
You're welcome.
No. Thank you, Ali. Thank you all, and you can also leave your comments and also other questions in the chat for Ali and for the other presenters. So we will go to the next presentation.
Hello, I'm Tian from Xianjiao Liverpool University in China. The project I would like to share today is a parametric form language for fiber-reinforced concrete prefabricated facade elements using 3D printed formwork. For a long time, there has been lots of digital capacities to create intricate shapes, but the digital flexibility is not well matched with similar fabrication methods. Many studies have examined the capacity of full-scale robotic 3D printing and 3D printed formwork for concrete architectural elements, but both have run into new challenges. For example, the structural performance and the limited application scale. Applying high-performance concrete with 3D printed formwork can potentially address existing limitations, but the constructive feasibility of digitally designed architectural elements in this approach is not well understood yet. The research employed this hybrid approach to develop a parametric facade form language. It examines the mutually enabling and constraining relationships between parametric facade design and material functional performance, as well as the geometry flexibility. The literature review was conducted from 3 aspects to review key works in the related fields, including the realization of freeform concrete facade elements, 3D printed formwork for concrete architectural elements, and 3D printed concrete architectural elements. This research extended this existing work by examining how material functional performance aspects can be integrated into a parametric form language to achieve facade geometric flexibility. So the general research question is, how can parametrically designed facade elements using 3D printed and fiber-reinforced concrete to produce geometrically flexible and structurally viable building elements? The sub-questions are respectively based on the design, material, and fabrication aspects. Accordingly, the research used a mixed research method. Design-driven method is used to demonstrate the facade form language design process. The empirical research method is used in engineering experiments and prototyping process to get quantitative data to inform the initial designs. The anticipated outcome include a parametric facade form language and material-informed design strategies, physical prototypes, and their structural performance database. The research contribution includes a new design approach, which involves mutually limiting and enhancing relationships between material properties and geometric flexibility. Also, the hybrid materiality provides a new method to develop architectural geometries. This research is planned into 4 stages. It has been conducted for almost 1 year, getting to the end of the stage 2. This stage involves the digital simulation and the physical experiments of the facade form language to inform the initial designs. At stage 3, it moved forward to the full-scale prototyping process and the facade framing construction. The last stage is the project wrap-up. The current progress include the literature review, printing experiments, and basic geometric exploration was further developed into a parametric form language design. Also, the small-scale fabrication feasibility test was also conducted to study the function of 3D printed formwork. The prototyping process is now at the initial stage. The feasibility test follows the conventional compression strength loading test. It is the typical cubic and cylinder shapes cast in both 3D printed and conventional formwork for compression purpose to check the structural influence of 3D printed formwork for this concrete components. The test brought the preliminary research findings. The 3D printed formwork not only can serve as a mold for fiber reinforced concrete, but it also seems have very few negative effects on the structural performance of the concrete components cast in the formwork. The preliminary geometry exploration for the facade form language design is concluded based on the criteria concluded from the literature review and previous experiments. The form language was designed parametrically, and it provides modular variations to achieve the design criteria. This experiment was conducted to get the proper data to be as the parameters to inform the initial designs. The spotting system and the toolpath design enable an efficient formwork printing. The thinnest formwork is selected from 6 modular prototypes for the chill to test the fluidity and even concrete fiber deposition. The finding of this test is the design geometry can be fabricated at a small scale, but the new issues arise in the casting process. It indicates that the design process should involve more relative geometric strategies to exert the air during the casting process. For the next step, I'm planning to scale up prototypes to further test structural performance to investigate the relations between formwork thickness, module scale, and geometric flexibility. I will also move forward to the performative facade design, since now I only consider the geometric aspects. Thank you. That's all for my presentation.
Well, thank you. Maybe Dejan, maybe do you want to present yourself very briefly, and then we can go to the feedback.
Yeah. Hello, everyone. I'm Tian from Liverpool University in China, and I'm very glad to be here to present my project and get all this valuable feedback from you. And I'm very sorry for the separation between the video and audio of my presentation. And I'm ready to explain the misunderstanding caused on that. And I look forward to your constructive feedback and comments. Thank you.
Thank you, Dejan. So, who wants to start? Birgul, please.
Okay. Thank you, Diane. It was a very clear presentation. I have two questions, actually. One is that because you are, your research question is, how can we design parametrically facade elements using reinforced concrete, fiber supported reinforced concrete? So did you look at the specialities of the facade, like the facade requirements? Because one way of doing the facade is not to put too much load on the building total load structure. And you're speaking about the concrete facade elements, that is the opposite things of the requirement. So did you consider that? Because concrete elements really, as a unit elements, have a heavy load, like load-wise may increase the total load of the building. So have you taken that into consideration in your design?
Yes, to answer this first question, I would like to explain the reason why I chose concrete firstly, because concrete is the most used material in the building construction over the last 100 years. And it provides the structural better performance and aesthetic and durable construction, but it's also responsible for the percentage of global carbon emission. My aim is to change this condition to make use of reusable formwork and to create geometric flexible geometries, and of course, because for the concrete construction, the most cost item is the formwork. So I think this is a way to generate a sustainable way to the concrete construction. And to answer your question about the weight of the concrete and the, I have think about that. And my design criteria for the concrete facade elements is one of them is to decrease the material efficiency. To increase the material efficiency and to make it as a structural facade elements to bear the wind load and as well as the self-loading. And yes, that's yes.
Okay. Well, I will have just short comment. Like in your consider that the concrete is the element that can really end up as a waste at the end of the day. So it's creating waste building structure. So looking into the less waste generation in the construction processes. So what could have be done in the future related to that? You should put into consideration. Okay.
Yeah.
Really. Element that we would like to use in our future construction. You try to avoid as much as concrete in our future construction. So that's just a question mark in your mind for future research, okay?
Yes. Okay. But from my opinion is to use less concrete in the future, but it is the other way is to use new environmental material to adjust this low carbon emissions. But I think the new material construction in the real architectural construction, it may need a long time. So I would like to focus on the current condition to decrease the cost for this recent concrete constructions.
Thank you. Dejan, Birgul, another question or feedback? Huda, please.
Thank you. Thank you for the very clear presentation and very well structured as well. I think the format you use, it's much clearer than the previous one, if I say. And your questions very clear, give a very nice introduction to anyone who's external to the project. I think you're taking the first step of reconsidering concrete as a sustainable material. So you're convincing us again of concrete and concrete viability as a material with fiber reinforcement rather than steel reinforcement. And this is, I think, the first step that we have to consider as architects and designers in how to select materials or rethink of materials. Mm-hmm. So I think you've took this step, which is very good, and started to relate it to other digital possibilities with prefabrication and molding, etc., and prototyping of those units. And I like the way you mentioned digital flexibility, because I always think digital means of thinking, digital means of exploration is a very flexible medium for all of us if we know the tool, if we have the skills to use those tools. So I do like the way how you presented the two words in one sentence. You mentioned mixed methods, for instance. I just want to clarify, what do you mean by mixed methods a little bit further? And the last question would be also related to context. What is the size roughly of those units that you are trying to develop? Thank you.
Okay. So shall I answer the design method question first? Okay, yeah. Based on my research question, my design is planned into 3 stages. The first one is to design the facade shapes first. Is the preliminary design, and then is moved to the experimental test, like engineering test, and to get the qualitative and the quantitative data, and of course the prototype to get this kind of data. So the design process, I use the design-driven method to propose this design process, and of course a new design strategy. And so for the last prototyping and experimental process, I will use the empirical research to get both qualitative and quantitative data to inform my initial designs. Yeah.
Okay. Yeah. Thank you.
And sorry, I forgot the second question. Yes.
Just to relate what you're trying, to do hypothetically with the real context of, architecture. What kind of, roughly the sizes of those units or components you're trying to develop? Roughly.
Yes. Yeah, as you can see in my presentation, I use the modular system, and for each modular unit, I assume that at this stage it will be 1 by 1 meter, and but at this stage I only conducted a very small prototyping process. It's about 25 centimeters. And yes, I know that when I move to the actual one-to-one scale, I will meet the other challenges. But yes, at this point, the scale is fixed at 1 by 1 meter.
Thank you. All the best.
Thank you. Maybe another question we have.
All right, go ahead.
Yeah. Hi.
Yeah, I think it's a very, I actually like this topic, 3D printing, concrete is fun, creating all this geometry, and you created, and your research question is actually clearer this time. But I have to ask, actually my question was some other question, and then until you said it's 1 meter by 1 meter by 1 meter, this is like quite shocking. Because for concrete, this size is actually quite big. And I'm just wondering, are you going to include reinforcement? Because 1 meter by 1 meter, if you print it, if there will be some structural problem. If you are just going to be a sculpture by itself, it's maybe possible, but you are going to give it a facade. This is, one building facade, that kind of stuff. It's going to have loading from, there's a lot of all this stress loading problem. How are you going to resolve this? I mean, if you're going to have all this reinforcement, it will be created some other problems. So this is my first question.
Yeah, to answer your question is, I chose the fiber reinforced concrete in order to get rid of the traditional reinforcement, and it's high performance concrete, and the target compression strength is over 120 MPa. So at this point, I think this is a very strong structural performance. And to answer your question is the main loading is the self-loading, and of course the wind loading, especially for the high-rise buildings. So I will accordingly digital simulated this kind of loading, and of course the physical test to simulate this self-loading and wind load. Yes.
Yeah, so actually, because this structural loading is actually not really the key research of your research question. So just going back to your research question about this parametric, for what is the parametric? What's the terms again? Yeah, parametric form language. So I'm just wondering where, right now you are testing with this form, this little twisting concrete. How do you actually come up with this form? Why does this form actually is the best way to evaluate your research?
Okay, to answer your question, I have to say this is very initial prototype of this design. And the reason why I chose the Evan Howard shape is that firstly, it's suitable for the modular system, and it's mostly suitable for the facade system, if I was not mistaken. And of course, the facade shapes should can achieve some facade functional performance such as shading. So I think this shape is very is great at this point to achieve this shading variation. And of course, when I move on to the larger scale, when the structural performance is good enough, maybe I will increase the geometric complexity in the later stage. So it's step by step. It's just a very initial prototype.
Okay, because this will actually. Since this is a prototype, it will actually affect where you comes at a later stage, because your title is actually parametric form language. So you might have to be quite aware how this actually be related to the curve, the kind of script, the language. Okay, yeah. So you might have to see how this actually be related. Because after you do all this testing and then you realize this form and shape is nothing to do with formal language, then it's going to be a big problem.
Yeah, I do agree with you. And I want to say that this kind of shape is also not very easy to fabricate in one-to-one scale, especially in the conventional formwork. So it's a starting point. And I agree with you that I should always come back to the parametric form language to think the information from the prototyping process. Yeah. Thank you.
That's all from me.
Thank you.
Just to add a couple of comments, I'd agree with the rest of the panelists. Firstly, I thought it was a very good presentation. I thought you'd achieved an awful lot in the time you've been doing your PhD, so well done, because I think particular aspects were really well organised, like the literature review was very clearly structured, you had key references in place, so that was great. And I think just really almost picking up on Sky's comments about the research process, I think it's really it's useful that you've done this kind of physical testing of a kind of a small scale prototype, and then it would be a great opportunity now to go back and actually think about your research question again and think about how the learning you've done through the process of making and testing can actually open up the opportunity, which, as I understand it, is really to think about the design potential of this approach. And so, you know, rather than the conventional PhD method of like narrowing in the whole time, maybe this is the moment where you have to give yourself a bit of design freedom to think about the opportunity of the technique that you're looking at. So it was a comment really more than anything else.
Thank you. Yes, I also discussed with my supervisors last time, and we think in the same way. It's just the right time to get back to the designs to see the potentials. Yeah, and yes, I will move on to that. Thanks.
Great, thank you.
Thank you very much. We don't have much time, I think, but I just want to add a little comment also. I think that, as Kai said, the parametric form language seems to be the core of your thesis, and maybe it's important to take a step back and to look again into the question, the research question, and the core of the thesis. Because maybe it's not so related to the structural performance. I don't know. It's just I'm asking myself that, and regarding that, maybe it can be more interesting to look at the limits. I mean, the physical, mechanical, structural limits on the fabrication, not the structural in terms of the facade, but in terms of how to fabricate these pieces, because you will find some really physical, geometrical, and mechanical limits for the fabrication. So that's, I think maybe it's more small, but at the same time relevant for this parametric language. Just a comment to think about. And
I also collaborate with the civil engineering expert and the students to collaborate with me in this project. So yes, I also got a very valuable feedback from civil engineers for the mechanical test. Yeah, thank you.
Thank you very much, Tian. And then we'll.
Hi everyone, my name is Begüm Aktaş. I am a PhD student at Istanbul Technical University. I am here to present my ongoing PhD research, Circular Facade System Design, through design for remanufacturing. My primary advisor, Professor Birgul Çolakoğlu, and my thesis committee members are Assistant Professor Cem Altun and Professor Tuğba Koçatürk. The brief agenda for today is to start with a short review of architectural design computing graduate program. Then I will continue presenting my PhD research. Architectural Design Computing is a graduate program under the Department of Informatics, provides training at master's and doctoral levels. It's a 2-year master, 4-year PhD program. First 2 years, students are required an elective courses and prepare for qualification exams. After examinations, students are expected to begin PhD research. At the end of 4 years, students defend their thesis. You can reach the detailed information through the website. I will talk about my problem statement. Today, the world has encountered with a global warming and climate change, and the construction industry is the main cause of human-driven climate change for 40% of carbon emissions globally. Every year, we are consuming 100 tons of materials. It causes a 1 degree warmer. In the 2019, we emitted 59 tons of greenhouses globally. 80% of the emissions are linked to housing, mobility, and nutrition. According to the Circularity Gap Report, in 2019, global economy is only 8.6% circular. During the pandemic term, it is expected to decline. To keep our world livable, we need to double global circularity to 17%. In that sense, this research focuses on the shift from the current take, make, dispose model to take, make, remake model. The problem statement of my research is a demand for a facade design by considering the circular economy principles to decrease the carbon emissions and raw material scarcity by keeping material in the closed loop with the help of digitalization in the traceability of the material in the supply chain to consider its end of life, like how the recycle, reuse, remanufacture, and refurbishment will work. My research questions are: how can facade system be improved in terms of circular performance as a long-term sustainable strategy? What are the available guidelines for the facade to be adapted to meet the facade guideline demands while keeping the circular aspect and material properties into account? How can digitalization in manufacturing and supply chain system be effective on the life cycle of materials, components, and waste for considering the net zero emissions and embedded and operational energy of the products and materials? Which are the elements and connections that can be redesigned for remanufacturing in the circular economy? The methodology is to, at the analyze phase, what is facade system design? Then, how will it be synthesized through the circular economy, building information modeling, design for disassembly, and shape grammar? For the evaluation phase, what will be the value of this research? According to Enigma Founder Foundation, circular economy is a restorative and regenerative by design and aims to keep products, components, and materials at their highest utility and value all times. This butterfly diagram shows technical and biological cycle. In the biological cycle, the strategy is to restore nutrients into the biosphere while rebuilding natural capital. In the technical cycle, products, components, and materials are keeping circulation in the economy as long as possible. This graphic illustrates how the narrative of circular economy has developed over time, and it traces the circular economy and presents its history in the three periods: pre-1990s to 2010, 2010 to present, and further. It is seen that automobile and aircraft industries have the deadline for the circular economy, but for the construction industry, there isn't any defined deadline or plans. Circular economy is a concept in which keep materials and components in circulation to be constantly. It requires rethinking of design, manufacturing, remanufacturing, and consumer ownership to keep process in use as long as possible. A few of circular actions that provide the management of constructions are design for disassembly and material passport to facilitate source separation of end-of-life materials and increase recycling quality. We need to use the design approach to support systemic change because the circular economy lies in system thinking. The design process can help to look at the systems as a whole and identify interpretation points. In that sense, the area of R in the design process become prominent through the how parts influence one another within whole and relationships of the whole to the parts. The current construction industry is categorized as unsustainable due to its linear model and of material use. At that point, facade could be the starting point to shift to circular economy, because facade manufacturing factories have almost same assembly system like automobiles and aircraft industries. Besides, the operational energy efficiency of the building is significantly affected by the design and construction of facade system. Along with sustainable design approach, most researchers deal with the complexity of the buildings have used the theory of levels to define the building into the different layers that display different change grades and lifespan of building components. Every 7 to 15 years, building facade is changing, and most of these are not done in a circular way. Therefore, this research focuses on the facade. The following outlines covers the research hypothesis. Through the data-driven circular economy-based design approach, construction of cost, time, management, and the waste and the energy will be dramatically decreased, while sustainability and refurbishment in design and manufacturing will be increased. Digitalization in manufacturing and supply chain system through the integration of material passport and building information modeling to trace the embodied energy of the products and materials will meet the demand for circular economy. In the scope of this research, we will collaborate with the industry partner Metal-Yapı to study how to innovate through a system perspective in facade while considering the circular economy principles. Case study will be the facade of the Maslak Ocean Business Center that manufactured by Metal-Yapı. And my initial step is to disassemble the facade into the components, elements, and materials to measure the circularity impact of the facade, to find a way to shift this linear system to circular system. The assemble system of the facade will be decoded to figure out the assemble, disassemble, and reassemble system to define the generative system through the shape grammar. I will do this through the three elements of configuration as functional, technical, and physical decomposition as a part of reversible building protocol. Therefore, embedded carbon through making materials will be decreased, as well as operating carbon emissions. Detailed information from this research and designing on products, materials, and facade system will be guide for further research on circular facade system design. Expected outcomes are circular economy will incorporate the potential of reuse to extend material cycles. Considerations for this assembly made during the design phase will make the implementation more cost-effective. The database will show the projects illustrating material passports, such as added value, cost, waste, and carbon footprint that would be helped to support the business cases for architects, facade consultants, clients, constructors, and even for the demolition constructor. Thank you for your time and attention. I will look forward to hearing your thoughts and comments about my research.
Sorry. Well, thank you, Begum. And maybe if you want to introduce yourself very briefly, then we can go to the feedback.
Okay, thank you, Professor. I am Begum. I'm a PhD student at Istanbul Technical University. And my master thesis is also about the system design for the single curve facades. And now I'm working on the circular economy-based facade design and for the facade system design. That's all I can say. Thank you.
Okay, thank you. So, who wants to start?
Maybe I shall go first this time.
Yes, please.
I do have, your presentation is very clear from research question, background, and your research, the whole process basically is very logical. This is very clear, very easy to understand. In fact, I almost have no question about the whole process. So, I have a question in this selection of topic because all this thing is very theory. I just want to ask, how are you going to evaluate this design for this assembly and reusability? You have all these figures, data, and everything. Are you working with real architects? Are you working on some real projects to actually show that this is possible, feasible, that kind of stuff?
Well, we are working with the industry partner, Metal-Yapı. They are really big facade design company, and they are really building and constructing this kind of facades. And they are asking us to find a way to design this circular economy-based facade design because they are aware of they are using lots of raw materials, and then they know that they don't have any waste management system. They are really aware of, and they want to change the system. We are collaborating with them on working on this system, but I am also aware that to work on this kind of system, first I have to assign or define a measurement system because there isn't any defined measurement system for the circular facade design. We don't have any defined literature for this facade design. To make sure that my facade is circular, first I need to define this system. I know that I need a measurement system. Then I will work on my system to make sure that is it working or not working.
But in that case, it sounds like only a certain type of facade can be included in this circular system. Is it right? Or you are trying to make that every facade can actually be done this method?
It's really hard to say that every facade could be circular. It's a very long process. We haven't defined this kind of situations yet. Actually, in the construction, it's really hard to define the circularity. But I'm working on the double skin facade right now for the environmental issues. But I know that there are studies on the curtain wall facades. And in Delft, they are working on the curtain wall facade. And then they are trying to implement this system for the curtain wall facade because they are defining that curtain walls basically mainly used for the office buildings. And then we are mainly use the office building. If they are, their hypothesis that if we find a way to circular this curtain wall facade, we will make a big impact. And my thesis will be focused on the double skin facade, but in the future, I don't know yet, but we haven't defined it. Maybe we will find a way to system design for the whole facade systems. But I'm at the very beginning right now.
Yeah, because I'm just afraid that you will end up becoming just another ideal situation of theory. Because right now all the things comes in diagrams and drawings. But to me, at the end of the building, when you dismantle a building or when you remove a building, it's just a mountain of waste. I have no idea how this become, be reused and this remanufactured. So it will be better to be much more impactful if you have real images, real stuff, that kind of stuff. So yeah, just my little comments.
Yeah, that's why we are planning for the next 6 months or say next year, working on the real facades, not just in the theory. Because if we are working in the real facade, we will see that we are what we should look for the furthers. Otherwise, as you said, that we are in the literature, in the theory, we don't have any progress.
That'd be good. That'd be nice. Okay.
Yeah.
Thank you. Is there another question? I have some, but let's see. Maybe. Yeah, please, Birgul.
For Birgul, no, I will keep quiet for Birgul because I'm your advisor, so I will just keep quiet for this time.
I thought so. Yeah, Huda.
Thank you. You mentioned design guidelines. Can we know more about those design guidelines that you are working with at the moment? Is it European guidelines or Turkish guidelines?
No, in Turkey, we don't have this kind of guidelines for the circularity. Basically, I'm working on the European guidelines, and basically for the North European guidelines, they are working on this kind of things more than other countries. I'm trying to use their guidelines to implement the Turkish version, but we don't have any defined guidelines right now.
Excellent. So are you looking for modern build regulation as well to factor in? Because, sometimes we change regulation according to, disasters in materials or things have, come across in a wrong way, in a bad way, and we have to rectify what we have in terms of regulations, materials, etc. So are you factoring in those regulations or any changes in the future design guidelines that you have to make those facade or the system in general work with?
Well, I have to look forward to this kind of things because we are in Turkey. We are an earthquake country. We have to consider about this kind of structural stuff in any kind of disasters or in any kind of flood. We have to know our further steps. I am planning to working on this kind of requirements, but I haven't started yet. But it's in my checklist right now.
Yeah. Because, I think just referring to Sky's point about any demolished building will be or end as waste,
yes.
That would be very pity, within our industry. And this is the nature of our industry. So how to make those systems flexible enough to take on any new guidelines or any regulation, that would be perfect. for the system. I mean, and validation of the system that you're gonna hopefully manage to do or create. Thank you very much.
Yeah, thank you.
Thank you. Jane, do you have any question or comment?
Just brief comments to say, just to agree with the other panelists, that it was a very clear, very well organized presentation, and particularly the background and the context, it was very well justified. And I think it's an important piece of work that you're doing. So I think that's great. And I think the other thing that I find particularly compelling is that you are partnering with a developer, so you're able to actually look at the impact of what you're doing in a real world scenario, which is really important. And I'm really interested in the logistics of what it means. I mean, if we're thinking about circularity for any kind of building materials and components, what are we talking about? Reusing on the same building? Are we talking about moving to different buildings? And if so, logistically and kind of financially and economically and environmentally, what's kind of the impact of all of those aspects? Sorry, big comment question.
Well, there's two options. That some researchers working on using the one of the facades, existing facade, to use for the other buildings, and some of them suggesting to actually for my design in my research, we are focusing on the reusing the existing material. If we are going to upgrade our existing facade, if we notice that there's some kind of changes we need to upgrade, we will planning to suggest to upgrade for remanufacturing, the reusing the material, and instead of changing the entire facade, because as far as I search for that, I learned every 10 years they are changing the facade of the building for the aesthetical reason, not for the performance reason. If they are going to change this make this kind of change, we are proposing that you don't have to change everything, every part of the facade. You can just change some part of the necessary part of the facade. And I mean, if you are going to do this, you don't have to reassemble entire facade, partially assemble some of the facades, and then that's why you don't need to use lots of raw material, and then you will have a chance to use manage this best for the further situations.
Sorry, I was just going to briefly say, I think what's really interesting is it kind of suggests that there needs to be a continued conversation and engagement with, say, a developer and a scheme. So, you know, it's not at the point of the delivery of a building, you would actually want to keep that conversation going to enable the circularity in the future. That was mine.
Yeah, it's kind of a ownership partnership with the facade design and the user, the client. It's going to be a kind of partnership, and during the entire lifespan of the facade, they will have a connection to upgrade according to their needs.
Thank you. Well, again, just a comment or maybe an open question. You don't have to answer it, but in a way, I'm thinking that I think that you are thinking of a very developed and advanced kind of construction industry here, in a kind of an abstract way of what a construction industry is. But it seems that the thesis cannot or should not maybe be developed in this abstract way, but maybe must be located or should be located in a specific context. I mean, in the industry, in the construction industry sense of the context. And what I mean is especially when in most of the world, construction is not a consolidated industry as such, you know, because you talk about digitalization and like in a I don't know, fourth revolution kind of industry, but construction in most parts of the world is not like that. So maybe you have to I don't know, like to paint a picture of a much more specific context of an industry, of a construction industry, to think about how to develop this circularity there, and not maybe in absolute terms or abstract terms. I mean, but it's an open question. I don't know.
Yeah, well, for the circular tour of the facade, I am planning to work on the design for this assembly, actually the modularity of this facade, because I'm aware that most of the facade has a unique system, and then they are not using the dry connection system. Most of the facades has a wet connection system. And well, first I need to define this kind of, there is a option to turn this wet connection to dry connection and find a way the common modularity on this facade. If I can find a common modularity for this facade, it's going to be easy. I mean, I'm trying to implement the way they are using in aircraft industry and automobile industries. They are very common modularity, and then we know that they are using same material for the other vehicles. They are not changing everything they are not uniquely designed building vehicles. I'm trying to implement this kind of solutions to facade to find a way to find a defined and common way for the further.
Yeah, absolutely. That's what I mean. I think there is maybe or can be a gap between the automobile or plane industry and the construction industry, maybe in terms of development and advancement. But I don't know, it's just a matter of context and to define very well the condition, the characteristics of that industry. So thank you very much, Begum.
Thank you.
And congratulations. And we will go to the next presentation.
Hello, my name is Idek Go. I'm a PhD candidate at the University of Cambridge in the Department of Architecture. Before I proceed with the presentation, I must address my background as it helps orient my study and progress. Being trained in architectural design, my focus on architectural research is on design processes. I have recently survived my first year Viva, and as such, my research is still in its preliminary stage. Therefore, I seek advice regarding alternative ways to approach my research as I begin data collection. The working title for my dissertation is Bias-Mitigated Data-Driven Facade Design Generation of Social Housing in Singapore Using Thermal Imaging Information. This research aims to disentangle the designer's aesthetic subjectivity to the occupant's objective solar needs in building facades. The context of this research is Singapore's social housings and using machine intelligence to iterate solutions developed from on-site thermal imaging data. The theory of form versus function would suffice as a parallel argument for the occupant's need versus the designer's wants. These will be the dimensions of objectivity and subjectivity that define the boundary of the project. The research hypothesizes that the occupant's actual solar needs are significantly unrealized when prioritizing the facade's aesthetic qualities. Therefore, this thesis leans positively towards the architectural theory of function rather than form, and could reiterate that form should follow function in architectural facade designs of social housings in Singapore. Even in present architecture, the age-old theoretical argument of form and function is hard to avoid. Form often supersedes function to enhance marketability in architectural design. Form is closely linked to subjectivity based on producer outset bias, while function looks more objectively towards the user and needs of the design product. Unfortunately, this oversight of producer-user design hierarchy in high-rise housing is evident in Singapore. The design preference in a building's form to its functionality is apparent in existing social housings that adopt architectural styles unsuitable for warm and humid climates. Hence, the functional solar needs of the occupants are often not well considered when prioritizing aesthetics, such as the abundant use of facade glass as opposed to heat-preventive materials. Simulation and thermal imaging will be taken from 6 existing social housings in Singapore, selected based on 3 prominent architectural styles since its development in the 1960s. These are Art Deco, Brutalist, and Contemporary. Analysis of chronologically maturing buildings will account for design aesthetic and stylistic changes over 2 decades, and occupants' interventions based on their solar preferences after initial wear. Finally, conducting case studies of different architectural styles considers the decades of stylistic adoptions architects have taken to social housings in Singapore. Each building will be studied against the island's general climatic conditions over 3 months to collect incident solar radiation data over monsoon and non-monsoon seasons, accounting for changes in the occupant's use. Data collected will be used to teach rule-based machine intelligence to generate objective prioritized facade designs. The aim is to establish a synergistic and sustainability prioritized approach of intersecting objective design and subjective aesthetics in social housings in Singapore. The selection of thermal imaging for data collection is an alternative to surveying households considering the current world crisis. It also favors an objective collection of post-occupancy information that mitigates bias that may arise between surveyor and occupant surveyed. I appreciate your attention and thank you for this opportunity to be part of the 2021 World CAD PhD workshop.
Well, thank you very much, Idek. Well, you actually present yourself in the video, but if you want to add something specific to your introduction.
Hello, everybody. My name is Idek, and thank you for this opportunity to be part of this workshop. My direct supervisor is Dr. Renita Barthan from the University of Architecture, and I also have a supervisor at the National University of Singapore, Professor Rudy Stoops.
Well, thank you very much. And well, who wants to start questions?
Maybe I shall go first. Just want to check. Idek, are you Singaporean?
Yes, I am Singaporean, but I was born in Great Britain.
Okay, so how long do you stay in Singapore?
Mostly.
Or you don't stay in Singapore?
I'm currently in Singapore, actually.
Oh, okay.
Yeah.
So how long have you been in Singapore, or basically previously you have been in Britain?
I grew up mostly in Singapore and spent actually most of my time in the US also.
Okay, so you actually do recognize, okay, just to let you know, I'm Singaporean as well. So yeah, okay. I do understand. I do understand the problem of your question, and it's a very it's really a big problem to even in my view, you know, all the aesthetic and the solar needs of things. So I'm just wondering, because the question here actually used thermal imaging information, but in your presentation, you didn't actually show how this actually relate to the aesthetic. You know, you are just looking at form and, you know, the kind of this thermal simulation and everything, but, you know, your thermal imaging and this aesthetic, because, you know, you have this little image with all this social housing aesthetic. So what's the relationship? How do you actually, how does this data actually can be related to the aesthetic?
So the data would be used as a way to gauge whether the aesthetic styles that were chosen by the architects in Singapore is relevant to our climate. So it's used more as I would say, how do I explain this? It's a good question, by the way. As a way to understand whether the styles used in Singapore is suitable for our weather. And then using the data to generate other types of facade designs to see what bias mitigated way of designing would, free from aesthetics, would come up with, and use it as a comparison between what is produced and what can be produced for the actual climate of Singapore?
Because the question comes because the solar needs is much more on the indoor, it's much of the building performance. But when you say thermal imaging and aesthetic, is the outlook. So, and in the first place, when you look at thermal imaging, it's kind of very general, you know, this color coding and everything. And how does it actually can give you specific information on how you design the facade? You know, whether this line, you know, or this little thing. So how can it be that specific to actually inform you on the design, on the design factors?
I'm using thermal imaging more for how much intervention the occupants actually do to the window or facade in this case, in order to prevent heat from entering the house, and how the preventive materials affects how the exterior facade looks like. And from that, I can, based on the data, I can compare what is actually needed by the occupants inside and how much they change the outside in order to suit the climate, in response to the climate, I guess. Yes. I hope that answers the question.
No, it's okay. It's just some questions for your you know, just think your future. Okay, that's all my side.
Thank you.
Maybe I can continue with what my understanding is that, like, you haven't really raised yet the research question. ASCAAD law presented. It is a problem in Singapore, this facades that has been built without consideration of the heat and sun. That's a problem that needs to be solved. And you are looking actually to generate solution for the existing buildings, current conditions that are really struggling with this issue, or for the future, for the next generation housing, considering this problem, how they will actually be designed, actually how their facades will be designed, taking into account this problem. Because there are two different things, as Christine pointed out in the chat. If you want to study alternatives, you will have to simulate the building facade and then check what could be the alternative or solutions to prevent these deficiencies of the heat, sun, and physical uncomfort that is generated. So you haven't decided yet that. You just pointed out that's the problem, and this is the problem, and you measure the problem with the thermal readings, and you are at that stage. So you have in mind which direction you're planning to go?
Yes, it's more for the understanding of for future building purposes, where how we adapt styles of, for example, the Western culture, Western society, into the context of Singapore, such as, for example, contemporary buildings or glass facade buildings, which use primarily just non-heat preventive materials, just single wall glass, for example. And we adapt that to the style, that style into Singapore, where it's totally not suitable for the climate. It allows too much heat, too much warming. As such,
that's a global architecture, isn't it?
Yes. Yeah.
Globalization.
Yeah. So it's for future the future of architecture in Singapore, to see whether adapting other styles in the future is suitable for Singapore, and is more like a case study of what is currently in Singapore, the different styles, and how that is suitable or not suitable for the current climate. And it's just, I think that maybe answers the question.
Okay. I mean, probably the global architecture did not have really considered at all the climatic issues when they were designing. So maybe what you're saying is for Singapore could be generalized for whole other parts of the world as well, because we are dealing with the parameters of the natural parameter, physical parameters. So if you have in your local culture that has dealt with the issue of the heat, sun, and etc. on the facades, maybe that could be put it as an input and then transformed to do new designs. That could be the only, I think, input from the local. Otherwise, whatever we do with the physical parameters could be also used as a global parameters for any kind of buildings that will be used within the conditions of this climate. So that will be all from.
Thank you.
Thank you. Is there another question or comment?
Yes.
Huda, please.
Thank you. Very interesting project, I would say, and as it's clear for everyone, it's really a common problem in everywhere in the world. I think even in the Middle East and North Africa and Asia. And the problem that sometimes we copy styles without thinking of them or adapting them to the local context. So from your description, really, I think because you are at the early stage of the PhD, you're looking at baselines that you would like to create based on the existing buildings that you identified as case studies. And then you're looking to maybe propose some interventions later based on your knowledge as an architect and designer and researcher. So I think from the main selection of case studies, you're looking at the climate as the main variable, and also the orientation would be also a very important variable. And another type of data you mentioned is the interventions by the users themselves. So you're studying the three, let's say, variables by using thermal imaging. So my question would be how you're going to use that information to inform you of what kind of, let's say, generation system that you put in place as a researcher to mitigate all these problems, or what you're going to pretty focus on later as the main measures you put yourself under the baseline.
That's an excellent question, Professor. So the initial plan was to use the thermal imaging data and insert it into a GAN's generative as a versatile network model to generate different different images of thermal images based on what information is given. But I understand that that comes with issues whereby it's very generalized. It's based on specific buildings and specific occupants. So I've moved on to that, and I have decided to use the thermal imaging data and adapt it to rule-based machine intelligence through using, at the moment, percentages of how much preventive measures occupants have taken individually between each households, and taking an average of that and transposing that into a new design, a new facade design for the same building. So that's how I think this project will move forward from here. But I do appreciate some feedback with regards to that, and whether that's a good way to move forward. Yeah.
Okay. So maybe the framework you're gonna have to come up with will be more focused on a new build rather than changing the existing performance of those, facades.
Mm-hmm.
Right? Okay.
Yes.
All right. Excellent. Thank you.
Thank you.
Okay. Thank you. Jane, please.
Yeah, just to add a couple of comments. I think firstly, I think the presentation was really interesting in terms of the narrative and the language that you chose to use to kind of explore the territory. I think the idea of bias is a really interesting kind of term to use and quite a provocative term to use. So I think there was something very interesting about the way you were using language. So I just wanted to pick up on that. And I did feel in this conversation that there's, you know, the people that seem to be missing from this discussion when it's very much about local, kind of the impact of the local, are the residents themselves. And I think it would be quite interesting. I know you explained that you, given the circumstances, you wanted to do the thermal imaging, but actually I think a conversation about how people have adapted to these buildings would be really interesting and potentially give you some kind of a different kind of insight that might enable you to avoid bias or generalization through the kind of findings of just having a very much data-driven approach. I just wonder what you think about that.
I do agree, Professor. It's a really good point. My supervisor, Dr. Renita Bardhan, did initially suggest that the main part of my data collection was surveying households and asking for their opinions of what their current situation is and how much preventive measures they have taken. It could be a small part of my current research at the moment because I'm focusing more on bias mitigated design processes as such, because I felt that taking surveys is very subjective in a sense, whereby it's very hard to form a metric to justify what is a good preventive measure and what is not a good preventive measure, or what is a good facade design and what's not good facade design, especially for occupants who do not have backgrounds in architectural design. It's very hard to justify that. So it could work synergistically together, where our used more objective thermal imaging data and also relate that to surveys as you suggested. And maybe I could somehow produce a more holistic research outcome from that. I think it's good advice. So thank you.
I look forward to hearing a bit more about the kind of the buildings that you actually work with and the details of the project. I think it'll be fascinating kind of a year down the line. Thank you.
Thank you.
Thank you, IDEC and the panelists. I have, I mean, at first I thought that I had the question if it is an historical kind of study, because you analyze historical buildings, and then I thought about the title, because you said something about data-driven design, and for data-driven design you will need a lot of data, because it's usually it deals with a large amount of data. So I think you have to decide here if you want to go to the really data-driven design, or if you want to combine these, let's say, quantitative data with some qualitative data, as Jane said, to reflect about this biased kind of building, as you said. And I'm very interested in the concept of mitigation. I think it's a very interesting concept that you just mentioned. But I think in a way it's reflecting about the actual buildings of the city and not the future buildings of the city. And I don't know, it can be interesting and also can be more like situated in terms of Singapore and the problems and the context. But I don't know, it's just again, an open question or a comment, but beautiful, congratulations. Well, so we will go to the next and final presentation.
Hello, my name is Deborah and I'm representing SIGraDi in Latin America in this worldwide workshop. I'm currently a PhD candidate in architecture and urbanism at the Federal University of Viçosa, Brazil, and I'm developing the research entitled Algorithmic Modeling for Simulating Green Facades. The research is being supervised by Professor Martinez and co-supervised by Professor Zuin. It is important to emphasize that the university we are working on in this research is one of the pioneers in agricultural science graduation in Brazil. And because of its importance and scientific experience in the area, there is a lot of incentive to research plants such as botany. The Viçosa campus has a large area for field experiments and a network of collaborators specialized in plant improvement, managed by the Plant Science Department. Another important point is that the university has a research group specializing in algorithmic modeling and computational processes linked to graduate program in architecture and urbanism, the laboratory No. This reinforced the work's methodology and united two areas of knowledge, botany and architecture, allowing for an interdisciplinary character for the research. Our focus with the collaboration is to obtain knowledge and botanical data to feed a digital model that represents climbing species for green facades. Regarding the object of this work, in a systematic review with 146 articles, it was identified that there is a greater interest in studies supported by experiments and the system's thermal focus, with only 6% of this material focused on algorithmic modeling. The review also highlighted some problems with studies that use simulation to analyze vegetation. We identified that the similarities do not consider the plant's dynamism, generating some uncertainties after its constructability. This is because each species has specific characteristics and needs for development, such as time for growth, loss of leaves, and the overload of this vegetated mass on the structure of the plant panel. This problem is mainly linked to the lack of a specific model to simulate the green facade and also by the lack of a botanical database referring to the modeling of these elements. Therefore, we start from the hypothesis that by associating botanical parameters to algorithmic modeling, we can predict the dynamism and estimate some structural issues along with its development. However, to solve this, we need to answer the following question. How to associate leaf cover parameters and vine's vegetated mass in the algorithmic modeling of a vertical plant device? Answering this question and proving the research hypothesis, we intend to develop a specific code to simulate the conditions of growth and development of climbing species that can help in the composition of green facades. To solve these problems and reach our goal, we started our research by building 8 prototypes in the field with climbing species suitable for the high tropical climate. These prototypes are isolated without contact with construction to analyze only the species. After planting the species, we followed the development and growth for 12 months, going through all seasons of the year. With this monitoring, we obtain the parameters of leaf coverage, and after a year, we extract leaf density and vegetated mass. It is noteworthy that we chose to work with some seedlings in pots to observe the plant's development under these conditions. After gathering the parameters, we entered the second stage of the research. At this stage, we validate and investigate methods to enter the botanical data extracted in the field into a digital environment. The software used in this step was Rhinoceros with its Grasshopper plugin. Therefore, To represent the leaf cover, we use binary image pixels with only 2 channels, black and white. The images that feed the code were processed with ImageJ software. Were also quantified the percentage of leaf coverage of each image before the modeling process. To be able to read the number of pixels found in the images, it was necessary to create a surface that represented the same proportion and size as the original images. Then we subdivided the surface into pixels and mapped it with binary images referring to the 12 months of the year. Thus, we can control with a selector which period of the year we want to analyze and observe how the species has developed so far. With this process, we were able to validate and configure the code to show us the conditions of the plant during its growth phase and also its percentage of coverage in a given time. With this configuration, we were able to get close to the leaf coverage quantification given by the ImageJ software. With the leaf coverage defined, we were able to start some physical configurations of the green facade, such as the number of seedlings, height and distance of the seedlings, and type of leaf coverage. The next steps are to make some system configurations more complex, such as simulating the growth of vegetation in other meshes and surfaces, and configuring the leaf density to get an idea of the third component of the system. The last stage of the research is to use computer simulation to estimate the device's worst scenario to identify stresses caused by vegetation overload in the panel mesh. This step will also serve as a pilot study to discover the final form of this panel. For this simulation, we will use Caramba 3D plugin for Grasshopper and the following input parameters: surface, geometric patterns of plant growth mesh, vegetated mass, leaf cover, number of seedlings, and general dimensions of the device. With the procedure presented, we have already gathered botanical data from 8 climbing species for the high-altitude tropical climate. We validated leaf coverage using 2 software. We were able to test the developed and predict the foliage growth for 12 months, and we configured some steps of the system, such as the quantity and distance between the seedlings, growth, and coverage of the facade. The next step is to draw some design metrics for the constructability of the system, indicate possible structural efforts to support the mass of vegetation on the facade, predict vegetation growth on more complex surfaces and varied meshes, create a specific model to simulate green facades, and provide botanical data for configuration and simulation of green facades. Finally, I would like to thank you for the opportunity to represent SIGraDi at the CAADE Worldwide Workshop, and to thank the Laboratory Law and the Graduate Program in Architecture and Urbanism at the Federal University of Viçosa for supporting the development of this research, to the Department of Plant Sciences for supporting the experiment, to FAPEMIG for the scholarship granted, and to all the volunteers who helped in the construction of the prototypes.
Well, thank you, Deborah. Do you want to introduce yourself briefly? Background, university context.
Em português, o professor vai me ajudar? O Rodrigo?
See, I cannot hear you very well. Maybe if you approximate.
Você me ouve agora?
Yeah.
Bom, a minha formação é em arquitetura, mestrado e doutorado também em arquitetura. Ambas as pesquisas foram desenvolvidas, estão sendo desenvolvidas na Universidade Federal de Viçosa, Brasil, e a linha de pesquisa que eu tenho focado e feito as minhas pesquisas é a análise do ambiente construído, com foco em fachadas. Agora no doutorado, especificamente fachadas verdes.
Okay, so I will help Deborah with the English. So she's a master and PhD. She has a master and PhD from the University of Viçosa in Brazil, and she's conducting research on construction, buildings, and now focused on these green facades. So,
is this her second PhD? You mentioned that
no. Master and then this PhD.
Okay.
In process, let's say. Sorry, it was my bad. So, is there any question or comment for Deborah?
Yeah, I can jump in. Actually, I find it very, very interesting, Deborah, your work. It's intersection between landscape and architecture. I think it's in between. I wondered, and it's promising, like it's the direction, but I wonder, it's slow. You, in your experiment, you actually planted some plants that have a physical ability to climb on vertical climbing. So, and your whole research is based on this one type of plant, isn't it? Did you like make a variation of the plants that behave in the same way? Now I will answer my question, because you actually looked at the leaves and algorithmic development of the leaves. So it must be one plant, one type of plant.
Deborah, ¿me entendiste o querés que traduzca un poco? Pregunta Birgul si usaste solo plantas trepadoras y si estás usando un tipo de planta o varios tipos de plantas trepadoras.
São plantas de espécies trepadoras. Eu utilizei 8 espécies que são aptas ao clima local do Brasil e avaliei somente essas, mas a condição do trabalho é ampliar essa biblioteca de trepadeiras, poder fazer outras famílias, né, de trepadoras.
Yeah. So she said that she's focusing on climbing species of plants, only climbing for now, and she's experimenting with 8 different species of climbing plants. I don't know, Birgul is
okay, that's fine. And is there like they will be used as a second facade, like a green facade, like the plants will be actually growing as a second facade on the existing facade. Am I right?
Pregunta Birgul si las plantas funcionan como una segunda fachada.
Isso, ela é como se fosse uma cortina verde. Vai ser uma espécie de sombreamento natural, bioclimático.
Yeah, like a green curtain of the facade.
Did you consider the maintenance of this facade and other like climatic conditions, because the plants behave very differently based on the different climatic conditions? So it may not be, we may not have a results as we wanted, because they can suddenly have a like disease and drop all the leaves. They can have bugs on it, and that they can really disappear, and etc. So how these facades will be sustainable, survive as we want them as a building element or component?
Si pregunta sobre la sostenibilidad de las fachadas en términos de mantenimiento, porque pueden tener enfermedades, las plantas o insectos, no sé, ese tipo de cosas.
Então, por isso que o experimento que eu produzi no doutorado, ele foi conduzido durante 1 ano. É pouco, mas o ideal, óbvio, seria acompanhar mais anos, porém, para conseguir ter uma estimativa de tipo de praga, tempo de crescimento, qual espécie fecha mais, né, a cobertura dela é mais densa, é necessário passar por esse experimento. Claro que ainda eu posso ter alguns imprevistos, mas eu já consegui captar uns 80% do que eu posso encontrar mais à frente, né, com essas espécies que eu escolhi. E como conduzir elas de uma forma que se mantenha ao longo dos anos.
Yeah, she said that she's, well, actually, she had a 1-year study on the plants, So she tests all the conditions, let's say, of the climate changes for 1 year, and she's expecting to expand this for at least 1 year more, and to look at diseases, possible diseases, and climate changes, and so on. And the species are local species from Brazil, so she's not thinking about other contexts, let's say, in the world for now, but she's situating the research in Brazil specifically.
Okay, the one last comment will be, I mean, like the futuristic approach for this is to genetically modified plants. Genetically modified plants defined that will be used as facade elements. And I will stop here.
Dice que una manera futurista de ver esta tesis sería pensar en plantas genéticamente modificadas para que sirvan a las fachadas de una manera ideal, ¿no? Optimizada.
Eu não sei se eu entendi a pergunta, mas ela quer saber se esses tipos de plantas podem ser, eu consigo aplicar outras em outros locais, né? Seria isso? A ideia é tentar reunir uma biblioteca no Brasil, fazer uma biblioteca das espécies tropicais, as que são aptas ao clima do Brasil. Porém, a pesquisa pode ser ampliada para outros continentes, outros países, outros climas, porque eu vou disponibilizar uma metodologia para seguir como coletar esses parâmetros que são importantes para avaliar o desenvolvimento da espécie. Então, acredito que vai ser uma forma de expandir essa biblioteca, porque não se encontra na literatura em local nenhum. Então, seria um ponto de partida, né?
Yeah, she said that the expected result is to have a library of plants and behavior of the plants, and this parameterization of the growth and so on, and performance of the plants, and then obviously the methodology and all the parameterization can be also applied to other contexts and other kind of plants. Just thinking about the experiments you have to do first, or the studies of the plants you have to do first, but the methodology will be useful. So are there any other questions or comments?
I think I will follow up the questions. This is a very interesting topic, you know, using plants growing, and actually it's fun to me, you know, doing all this but and in the first place, you know, looking at this research, you have a very clear research question, and you have a very clear methodology all the way to evaluate, you know, whether this is workable. So I think this is a very logical process and very clear, but I do have one questions, and that is the foundation of this methodology. Why do you use pictures and pixels to actually simulate the growth of the plant? Because you have one images where, you know, the plant actually grow until the whole images is black. It's almost to me like this vine can become a forest to the extent. So how do you actually how does this actually really represent the growth of the plant?
Sí, Sky pregunta, primero dice que está muy bien organizada la presentación y que la pregunta está muy clara, pero pregunta por qué en la metodología utilizas píxeles, imágenes en blanco y negro, para simular el crecimiento y parametrizar el crecimiento, si realmente refleja el crecimiento de la planta, porque hay un momento que se vuelve completamente negro, por ejemplo.
Eu utilizei os pixels por conta da facilidade de criar o código. Eu achei que fosse ficar mais leve, mais interessante para eu conseguir acompanhar a simulação numa fachada real. E eu já vi que metodologia dos pixels foi utilizada em outras pesquisas, não na modelagem algorítmica, mas em outros experimentos. Então, é uma metodologia já consolidada, por isso que eu optei em utilizar ela. E eu acredito que vai, assim, apesar de eu não ter como prever 100% o comportamento da planta, o conhecimento que eu adquiri com ela durante o ano, de como ela cresce, o tamanho, a direção que ela cresce, cada espécie tem uma característica, né? Então, eu sei, por exemplo, que espécie X vai crescer para o lado esquerdo, a Y vai para o lado direito. Então, eu tenho como ter essas respostas. E tudo isso eu pretendo passar nessa biblioteca de informações e parâmetros da planta, que vai ajudar com as imagens.
Okay. Well, to make it short, she said that actually the methodology of the pixels is already consolidated in the literature of the botanical literature of analysis of growth of plants, but it's not taken to parameterization. So she's taking consolidated methodology of the botanical field to the architectural field, taking this parameterization strategy.
Ah, I see. Okay, this is very interesting. Then in that case, my next question will be, because on our side, when we run all these parameters, we have all this biomimicry, calculation algorithm and everything. We have all this, chaos theory, agent-based. We have something very similar to this growth as well. So I'm just wondering, how does this actually be much better on that side? Because you were saying they come from other the botanical field, bring it to architecture. How that it will be something very helpful to us, but compared to the one where we are more familiar with all these numbers, formulas, and everything, how do we actually, it would be better. It would be fun to actually see even this kind of comparison.
Well, Sky está diciendo que ellos trabajan con este tipo de simulaciones, pero usan teoría del caos, fórmulas muy complejas, y que sería muy interesante aplicar este tipo de metodología que viene de otro campo a este tipo de simulaciones que ellos usan en arquitectura, que son muy complejas y que por lo tanto analizan el crecimiento de una manera también muy compleja, y que le interesaría utilizar este tipo de metodología que parece más sencilla, ¿no? Es más un comentario que una pregunta, creo. Okay, I think she take it as a comment more than a question.
No problem.
But in a way, I think it was more kind of a. Huda, Jane?
Yeah, I commend her approach really, because with the ecological systems, we have very rich variety of complex and also non-linear dynamics. So kind of summarizing all this in one system of a green facade is a very challenging thing. And secondly, I think I'm very curious about the guidelines that she would like to develop at the end of that process. So does it include, for instance, what kind of greening area, like the percentages? I'm just guessing that not all the 4 elevations would have a green facade. Secondly, for instance, do we have a certain system for the design itself as any other facade system? And thirdly, what kind of greening system? So if she's telling us that she looked into 8 species, I think she mentioned, how the decision-making will happen if we are considering the 3 elements, the greening area, the percentage, and the system behind it. So that would be very, very, I think, useful for all architects and designers, just to become a little bit more familiar with such system and being able to use it. Second question would be, I'm always find it very difficult to know.
Can I ask the first, because I have to translate it.
Sorry for that. Yeah, Rodrigo. I'm pretending all the time that I am understanding Brazilian, but I'm not. Just to let you know.
Yeah. Well, what did you mean with greening area? Sorry, because to make the translation.
the greening area is the percentage of the total green area of a facade. So maybe it's 10%, 20%, 50%. I'm not sure. Yeah.
Okay. Entonces, lo que pregunta Huda tiene que ver con, digamos, con los criterios que vos vas a usar en el futuro, digamos, en los resultados, ¿no? Si vos vas a tener unas líneas guía para diseñadores y arquitectos que vayan a utilizar este sistema, y si en ese sentido vos estás pensando, por ejemplo, qué porcentaje de la fachada va a estar cubierta por esta vegetación, en cada caso, digamos, cómo pensar ese porcentaje. Si hay un sistema, digamos, constructivo o técnico asociado a la planta, ¿no? A cómo tomar decisiones en función, decisiones por ahí constructivas, en relación a la fachada. Sí, creo que básicamente serían esas preguntas. Y en relación también a las especies, ¿no? De cómo elegir qué especie sí, qué especie no.
Então, a ideia do resultado final do trabalho é exatamente isso, eu conseguir disponibilizar não só uma biblioteca para quem pretende trabalhar com simulação com as plantas em fachada, mas também poder dar alguma diretriz inicial, assim, um norte, para quem quer construir esse tipo de fachada, arquiteto, paisagista, pode ser engenheiro, qualquer projetista que tenha acesso ao código vai conseguir prever, por exemplo, no verão, qual espécie que vai me proporcionar mais sombra para conseguir me ajudar com a questão de temperaturas. Eu não vou fazer análise térmica, mas eu sei que aquela espécie vai me ajudar a bloquear um pouco o sol. Então, essa porcentagem tem importância porque algumas espécies elas não cobrem totalmente. Elas perdem folhas ao longo do ano, elas não crescem não fecham 100%, tem mais raízes do que folhas, então tudo isso vai afetar não só na estética, mas como na estrutura, quantidade de mudas que eu preciso utilizar, espaçamento entre elas, então eu pretendo dar tudo isso como um direcionamento no final do meu trabalho.
Okay. ¿Y cómo se eligen los parámetros a la hora de tomar decisiones por parte de un ingeniero, un arquitecto?
As plantas, como escolher as plantas.
Todos estos parámetros térmicos, de crecimiento, de estéticos, ¿no?
Eu acredito que vai depender muito do seu objetivo, do que você espera, né, com aquela fachada. Por exemplo, se for uma construção que só precise cobrir por conta de muito excesso de sol, você vai ter que optar por uma espécie que tem uma densidade maior, que cresça mais rápido, vai precisar de mais mudas ao longo daquele perímetro, e ao mesmo tempo você vai ter que avaliar essa questão estrutural que é relacionada à massa vegetada, que eu já vou também dar um direcionamento. Então, por exemplo, se fosse na questão térmica para o inverno, qual seria uma espécie mais adequada para que não fique tão frio no momento que não tenha tanto sol? Então, eu vou conseguir dar alguns insights, assim, algumas direções para poder adaptar a cada condição.
Okay, well, so she's saying that, well, actually she's taking into account this aspect that you mentioned, and she said that the way to approach the decision-making, let's say, process of making these green facades, it's related to the, let's say, like a previous diagnosis of the building that you want to, I mean, if it is an existing building or if it is a project, the conditions of the building, if you're talking about thermal condition, or is about light, or is about, I don't know, even the structural condition of the plants, like the load of the plants on the facade and so on. So regarding the condition, the existing condition, or of the context or the building, you enter with that on the, let's say, the parameterization, the library of plants that you have, and you can choose the the plants that benefit you. For example, if you need a plant that grows on the summer but not on the winter, or a plant that is green all the year and so on, you know. So it's, I don't know if it answered the question, but it's something like that.
I think I'll have to wait for the guide, but please in English.
Yeah.
Yeah, I mean, you mentioned the thermal conditions as well, and the comfort of people within the building. That's, I think, a very important criteria to consider. So I'm not sure, maybe this is a comment really, not a question. I'm not sure if Deborah has considered the U values, for instance, as one factor, because normally it's very vague with the green walls and, you know, green substance to know exactly how that would affect the performance of the total wall or the final, let's say, component of the wall. It's not clear yet. So maybe this is the next step for her after the PhD, hopefully. Yeah. Thank you very much. Yeah. Very interesting project. Thank you.
Bueno, ella te agradece, dice que es un proyecto muy interesante. Pregunta si no deberías agregar alguna cuestión en relación al confort de las personas, como a la manera de medir el confort de las personas, no solamente los datos duros, pero bueno, plantea que puede haber algunos desarrollos futuros después del doctorado y que está muy bien así también. Jane?
I'll just some brief comments. I think it's a fascinating project, and I think it's got huge potential. I'm particularly interested in the idea of the growing element within a building. It's something that we look at within our own research hub. So this idea of designing with the living, I think, is fascinating, and what that opens up in terms of questions, in terms of timescales, I think is huge, but fascinating. And I would hope that actually this research almost answers some of the questions that were raised in some of the other PhDs projects, where, you know, suddenly we've got this element that isn't necessarily permanent. It could be designed for disassembly, it could be replaced every year or every few years, and it's a very different way of thinking about the built environment. So yeah, I think it's fascinating. Thank you.
Bueno, te agradece por la presentación, dice que es una investigación fascinante y que ojalá pueda responder algunas de las preguntas que incluso fueron planteadas en las otras presentaciones, ¿no? Que este diseño con cosas vivas, diseño con lo vivo, es muy interesante y que ella está trabajando en un campo similar. Así que gracias. Bueno, so well, thank you very much, Deborah and the panelists. And now we have some time for a wrap-up, let's say general comments that you want to add to the session, things that you want to point out, maybe general advices for the students, the PhD students, or just comments to have a closure for these sessions, this session. So who wants to start? I don't know, maybe Birgul, following the...
Yes. I really enjoyed. There was a variety of the really good works presented here. I congratulate all of you and wish you good luck in your further studies. Some of you have already developed studies. Some of you are at the beginning of your studies. But my comment would be, whatever you are doing, whatever your research is, please consider the current state of the Earth and take into account how we can really make impact and in the current solutions or current problems of the world, how we can really help to solve these problems. Because as a constructive and design industry, we are the industry, architects and constructionists, that is the most, the biggest industry that is actually polluting the world. So whatever we are doing in our further research, we have to take into account all this problem of the world, and from one aspect to tackle this issue, to provide solutions, because we are the biggest responsible of the direction that the Earth is now going towards. So my comment will be that if you are in the early stage of your PhDs, please look at the problems and how this really can improve the current, whatever, system, product, whatever aspects you are looking for, that to reduce the impact of the construction and the design industry to the world. Thank you.
Birgul?
Maybe I shall continue. Just following Birgul's comments, I think everybody have a very beautiful PhD, very fun topics. Everybody having fun. I have fun giving comments and listening. So it's very lovely to listen to the PhD topics. But I would say just general comments, just to make sure that doing a PhD, it is very easy to actually fall into this loophole, just doing your own stuff. And, I think that's why Birgul actually give these comments. You have to look at how it actually, step up to look at how it actually contribute to the architectural field, how it actually contribute to the society. And of course, one thing is really looking at the scope of the research, where is your, where is your, this research actually falls into. And then also the most important part is actually really the evaluation part. How do you actually evaluate your research? Is it a algorithm, research, or a design method or something like that? So where to focus and where to aim. And in the first place, I have to say the comments which is now in my mind is IDEC, where he actually said he only survived the first year. I was like, wow, first year, you used the word survive. So, I mean, come on, this is something which, is going to be a long road. You have a lot of more research and method, and you're going to meet all these difficulties. So, feel free to come again. We will be here every year to help everybody.
Thank you, Sky. I don't know. Yeah. Huda, please.
Thank you for the amazing selection of projects, really. Thank you for the organizers and the participants. I think with the climate emergency, we are finally back to nature. We started to look into our, one project looked at the styles and how we can, improve that for the later generations, how we looked at the species, different species, and how to localize that decision-making, let's say, process. And also the intersection between buildings and urban spaces, I think, become clearer because the facade is the joint in between the two. And it is an opportunity for us to integrate greenery with increasingly density and also with all the factors that we are facing at the moment within our cities, especially after COVID and the experiences that we have. So it gives us a very high hopes, I think, about the high quality of life that we may experience in our lifetime. So yes, with all the proposition that the students made within their project, I think they will have to test their propositions and the hypotheses with more realistic approaches and make sure that everyone will learn from their projects and their projects will be applicable to what we are experiencing currently in the world everywhere. Thank you.
Thank you, Huda. Jane?
Yeah, just a brief comment. I mean, firstly, congratulations to all of the students, because I think you really were able to present your concepts and your ideas very, very clearly and with an excellent level of rigor. I mean, what I was particularly, I guess one comment where I was particularly interested was the idea of trying to engage with industry. And I think Begum's project, where she had a partner, an industry partner, and she was going to kind of be able to analyze through real world examples, I think is a really useful model to think about. And I feel for students that maybe are in an earlier stage of their PhD progress, that kind of engagement could be very useful. To do, as Sky had mentioned, being really able to, evaluate your findings and determine the real world applications of what you're doing. So I think that would be one suggestion from me. But I mean, I think they're an excellent set of projects, and what an interesting panel that we've listened to, because they kind of similar issues that are being raised, but different responses to those situations. So yeah, thank you very much.
Well, thank you. Thank you very much to all of you, all the students, all the panelists. I want just to add that maybe sometimes it's useful to think local to be global, and to think specifically to be general, to go through this process of the thesis, and also from time to time to think about the contribution you're making to the field, to the area of knowledge, and to think about the impact you want to make in the world, in your context mostly, and be precise as you can be precise, and take care of you mostly. I think is the most important part of all of it. And well, thank you very much. It has been beautiful and very warming event. I don't know, it was really beautiful. So thank you very much, and well, see you soon. You can also hook up tomorrow to listen to the other students, to participate maybe in the chat even. So let's see you around here. Thank you very much.
Organizers for everything. So see you on, I won't be able to join tomorrow, but on Wednesday, probably for closing, I will be here.
Well, see you.
Have a nice day. Good night. Good
Goodbye.
morning.
Goodbye. Good morning.
All the
Bye.
best. Thank you.
All
Thank
the
you.
best. Thank you.
Thank you.
Bye.
Bye-bye.